done at some point. And then it's a kind of a mental batch job runs in my mind for a number of months as I think about how's the best way of doing this. And then after a couple of months maybe, the batch job finishes, and that's when I'm in trouble, because that's when the coding starts. And yeah, this it's about a day, so it's quite modular. The code in here is quite modular. In fact, why don't I just show you the code?
You say it runs with 32K. If you've just got a console and just one cartridge in, can you just use the 16K?
No.
So you've got to have your 32K.
You've got to have your 32K, yeah. I would like to, maybe in a future version, because I want to get this finished so that people can start playing with it, but I like the idea of being able to run code from VDP RAM. It'll be slow, but, well, it won't be that slow, but I like the idea of it, so I'm gonna give that a go. But to give you an idea of the code, I'll have to minimise this because it's moved all my icons.
You know, I wouldn't say it's a major thing, but how difficult would it be for it to just run in the 16K bare console? Cartridge.
It would require quite a lot of rewriting as it currently stands. But if I was to do, say, a fresh version with that in mind, that's the difficulty. I didn't have that in mind when I wrote most of the code. And by making it run from VDP or from CPU, you actually get a penalty. There's a performance penalty even running from CPU, because it means that the bits of code which fetch the compiled tokens from memory gets bigger, because it has to be able to handle taking it from VDP, unless I use self-modifying code or something. But the code itself consists of quite a few files. I don't know, 30 or 40 different files, and it's just assembly. It's just pure hardcore assembly. I had a shock. I counted it, and there's 8,500 lines of code, so it's quite big. It's the biggest assembly language program I've ever written. So yeah, it's just hardcore assembly. Some of the stuff is written in Forth. I should be able to show you something written in Forth. Yeah, blocks. This code here's Forth. Although it's a different kind of Forth. What these actually represent are entry points into routines. Can you see here, for example, here's a dictionary entry. That's a link to the previous dictionary entry, which is this word here. This is the length of this word, and then following it is the beginning of the code. And these are all entry points. Like this is an entry point, and this is an entry point. All these words here are entry points. So this executable word called load consists purely of references to other words that already exist in Forth. And what you're actually seeing there, that is the loader, which loads a block of code from disk and compiles it. That's it. That is the compiler. Here is the interpreter, which is a combined compiler and interpreter. So this, where are we? That's this beastie. And it's his job to analyze what you've typed in, and if necessary do the compilation. And it's just a few lines of code. fact, it's not even that. It's just from here. That there compiles code. It's very simple, and running the code is even simpler. This is where it gets a bit shocking, actually. Perhaps I shouldn't show you this because you'll just think, "Oh, is that it? Ooh." Is it in here, or I moved it? No, I moved it. It's, I think it's in. Yeah, initialize maybe. Yeah. As I mentioned to you before, Forth code is simply a list of addresses, and I'll demonstrate that to you. I'll use the same program as before. Make sure it works. Yeah, okay. I happen to know that it always compiles at 8,000 hex. So there's a memory dump of CPU, and what you see is a link to the previous word in the dictionary, which is actually in ROM 7088. Length of this word, and then the ASCII, TEST, and then an address. That is the first executable. That's the address of the first executable code, which is actually, as you can see there, in 16-bit CPU RAM, the fast RAM in the console. That's a routine known as do call, or nest, as it's called in some routines. But all that does is push the address of this word onto the return stack so that we can come back to it later. And then we start executing words. So 718C is simply an address of a word to go and run. That's it. This is why code is very compact in Forth. And I happen to know, because I'm sad, that this means literal, which means that this is code, which means the next word in memory is to be treated as a literal and put on the stack. So we have here the value 100. So literal executes, looks forward in memory, gets that and puts it on the stack. Then we have another literal. You can see it just works its way along and runs.
So if it's just poking at an address for each word and executing that, what's sending it back?
These routines here. You have this one. That causes the current address that we are currently at to be saved on the return stack, so that we can branch and run another word. So if you think about it, all those are branches off to different words. Then you have this bit of code here. These 3 lines of code are the essence of Forth. That's the inner interpreter of Forth. That takes the current value at the program counter, puts it into register 6, looks at that, puts that in R7 and branches to it. That causes the code to be run. That's it.
But yeah, but at that point, what branches back?
What branches back is this. Which is a link to, we're probably getting more geeky than we should, but anyway, it's a link to this routine here called exit, which does a pop, a return stack pop, which reloads the address that was originally saved in this part, so code resumes from where it left off. And because of that, you can effectively nest unlimited, as long as you don't run out of return stack space. So yeah. Anything else?
Yeah, that's wonderful, Mark.
Or are we done?
That's brilliant. You obviously put a lot of time into that.
Yeah. 2 years, but not full time.
Anyway, stop.
Otherwise, I'd sack myself.
Now just a quick 10-minute break, and then we're going to go for